In this lesson, we focus on mathematics, MATH141, calculus, a UKZN module. We look at integration and its applications. Right, looking at mathematics 1B. Right now, we're finding the derivatives of the following functions. We've been given, we're going to first look at part A. I know that we had a hint on this, but I want us to have an open debate about this here. So y equals the cosh of the trigonometric sign of x. We notice that the angle is a trigonometric sign. This means the derivative of the cosh is the hyperbolic sign. Right, so we have the hyperbolic sign of the sine of x times the derivative of the sine, giving us exactly cosine x. And this is the answer to the first question. Right, from time to time, we shall obviously engage on these questions here, and we note our time is about 6:35, meaning we actually have to run up to like 8:35 unless otherwise. Okay, we have here in part B this derivative here, but now this one in part B, we have to take note of the following things. Y equals arctan x. This has the implication of the fact that dy dx is 1 over 1 minus x squared, where the modulus of x is smaller than 1. Take a look at that. So now, if you look at this carefully, we need to determine with precision the integral of this here. And so the question then is, how do we then proceed to find the integral of this here, if it is clear that the derivative of that is 1 over that, right? So it means that in the part B, we have been given y equals the hyperbolic tangent of 3x squared plus 2x. This means dy dx 1 divided by 1 minus 3x squared plus 2x. Then you multiply by the derivative of the angle or of the argument. The derivative of the 3x squared becomes exactly 6x plus 2. The answer becomes 6x plus 2 all over 1 minus 3x squared plus 2x squared. Any question? We move on to the next. Obviously, I mean, we check. So these answers indeed coincide and therefore confirm the correctness of our solution as well relative to the solutions that, you know, are part of the TAT. We shall do all the TAT. Yes.
Sorry, sir.
Yes, please.
May I ask, in the part where it, the thingy, I don't understand the derivative part here.
This derivative
when
part.
When you're doing the term. Yes. So you said 1 over 1 minus the x.
Yes, because the formula for the derivative of the arctangent, the hyperbolic arctangent, if you find rate of the arctangent, is always 1 over 1 minus x squared. Okay, that is the formula. So now, obviously, at this point, it generally, I mean, if it is the hyperbolic arctangent of x, then it becomes 1 over 1 minus x squared. But now the argument here is not just x. So we'll say 1 over 1 minus the square of this, which is the square of the 3x squared plus 2x. Then we multiply by the derivative, always by the chain rule, by the derivative of the argument. And the derivative of this In other words, we multiply by derivative of the 3x squared plus 2x. What is the derivative of 3x squared? It is 6x, and that of 2x is 2. Right?
Okay.
And then now we can realign things, because now this 6x plus 2 now multiplies 1. So we can just say the 6x plus 2 times 1. It gives us 6x plus 2 all over 1 minus, the 3x squared plus 2x squared, that way. Okay, take a look at that. What rules did we use here? We use what you call the chain rule. Right, what is the chain rule? Well, the chain rule tells us how to integrate functions of other functions. For example, we need to find the derivative of, suppose we need to find the derivative of the sine, the hyperbolic sine of 5x. Suppose we need to do something like this. Okay, it's going to feature there. How do you find the derivative of the arc hyperbolic of the hyperbolic sine of 5x? First, the derivative of the hyperbolic sine is the cosh. And then we write 5x. So first differentiate the outside of the function. And the outside is the hyperbolic sine, whose derivative is cosh, multiplied by the derivative of the argument of the function. So the derivative of the 5x is just what? 5. And this is therefore 5 the cosh of 5x. Okay, take a look at that. We shall be using this more repeatedly. But first things first, I want us to run through all the tasks today. And then we will have time also to go through the textbook and try more problems. In an attempt to make sure that we are very efficient in solving the TAT questions. The next question. Right, so the next question is part C. Right, I'm glad you're trying to reason this out. It's wonderful because learning happens when you try to engage with the ideas. But now in the part C, we have y equals the square root of 4x plus the cosh squared of 5x. Then we attempt to find the derivative. But first things first, for us to differentiate the square root, we must write it in a way that allows us to have an exponent, like so. We then proceed to find the derivative, dy dx. And therefore, this is 1/2 4x plus the cosh squared of 5x. You subtract 1, you bring down the 1/2. 1/2 minus 1 is minus 1/2. We multiply by the derivative of the interior. The derivative of 4x is just 4, plus the derivative of the cosh squared. You bring down 2. You have the cosh. Okay, then the derivative of the cosh itself is the hyperbolic sine. The derivative of the 5x gives us only 5. dy dx. 2 cancels. 4 divided by 2 is 2, and you cancel that. And then you have the 5 that is going to come out of that. But obviously, now this half here is in the denominator. So it's going to be half of 4 is 2 plus half. This half is going to cancel the 2 here. And there's a 5 that came from the argument. So we have 5 the cosh of 5x, the hyperbolic sine of 5x, all divided by. Now we have the following, because this is exactly 4x plus the cosh squared of 5x, like this. Now, the couple of things that remain very, very important. What are the things? It is the chain rule. That is the most holistic rule of differentiation. In other words, if we need to find the derivative of just this term alone, of the cosh squared of 5x, how do we find that derivative? First, to find the derivative, we bring down the 2. And then you have the cosh. So in other words, to find the derivative of this, you bring down the 2. And then 2 minus 1 as an exponent. And then we have the 5x like that. But next, if we like, we can write the derivative of the inside. Right. You see, by this, can write a bit more differently, in a way that will sort of ignite more understanding. For example, we can write this as d dx of the cosh of 5x all squared. What is the derivative of this? Right, you bring down the 2. Cosh of 5x. What is the derivative of the, now you have the 2 minus 1, which is to the power 1. The derivative of the cosh, which is the inside, because we just only brought down the 2 here, and we subtracted 1 from that. Bring down the 2 and subtracting 1 from 1 from 2, we have that. We proceed to never find the derivative of the interior of the function, which is the cosh, and then the derivative of the cosh is the sinh. Time the derivative now of the 5x, giving us 5. 5 by 2 is 10. The cosh of 5x, the hyperbolic sine of 5x. And this has given us the derivative of the cosh squared. By dint of that, we're able to see clearly the correspondence. And the fact that this answer we have, the 2 plus 5, the cosh of 5x, times the hyperbolic sine of 5x, divided by the square root of 4x, plus the cosh squared of 5x. You note that in the solution to C, there's a typographical error in the TAT questions, in the tutorial questions, because you're able to see that here in the denominator, they omitted, whoever typed this, omitted the power 1/2, or at least the square root in the denominator. Because whenever we started with the square root and it brought to the power 1/2, and then we brought down the 1/2 and then we subtracted 1. Like we had 1/2 minus 1 is the exponent, and then we multiplied by the derivative of the inside of the function. We continue. Okay, but yeah, we're just doing the TAT questions, and then we shall spend time on a lot of the other questions as well. Now, we continue to tackle the next question. D. Part D is as follows. Y is 1 over arctangent of x. But arctangent of x, 1 over that, 1 over is the same as the hyperbolic arctangent. And then obviously 1 over can be written as power to the minus 1 like this. What is this? This is the derivative. You bring down minus. You bring down minus. Arc, hyperbolic tangent. Then we have minus 2. So you bring down minus 1, you subtract 1 by the power rule and the chain rule version. Now we multiply that by the derivative of the arc hyperbolic tangent. But now the arc hyperbolic tangent, if you have it, we can find its derivative. The derivative is 1 minus x squared whenever the modulus of x is less than 1 for purposes of convergence. This becomes a series. Why do we have to say the modulus is less than 1? As part of the restriction, it is a necessary restriction. Because now this In mathematics, this becomes a geometric series. But the geometric series, we know that the geometric series from high school converges whenever the constant ratio is less than 1. Then we multiply here by the derivative of the arctangent. What is the derivative of the arctangent? It's 1 minus x squared. So what is the answer to this part D? See, they've typed the wrong answer in the tutorial. Right, so the derivative dy dx, okay, there's a minus here, minus 1 over, then we have the arc hyperbolic tangent squared 1 minus x squared, like so. This is the answer. But now what they wrote is something else, because I'm seeing minus 2 plus 5. There's no way you can get a 2 plus 5 out of this. There's no way you can get a cosh of 5x, the hyperbolic sign of that. Whoever typed the answer to D just took the answer to C, which had a typographical error of a power 1/2 in the denominator, and it was just carried forward. Okay, so take note of the typographical error in the solution to part D. There's no way that these two problems can have the same derivative. There's no way, because the 5x is from part C. I can see they've written it in part D. Why? There's no reason. Absolutely none. And the 4x, yes.
Yes, may I ask, can you please re-explain the parts where you said, you see the absolute value of x there?
Yes, it's less than 1.
So it has to always be positive or what? It must be.
Yeah,
I don't
always less
understand.
than 1. Always less than 1.
Less than.
Yes,
Okay.
in the derivative of the arctangent. Because why should it be less than 1? Well, because we said that the derivative of the arctangent, whenever you have the arctangent, its derivative must be what? Its derivative must be 1 over 1 minus x squared, where the modulus of x is less than 1. Why should the modulus always be less than 1? Often than not, they might not even ask you that. But it's very important to understand that this is a geometric series. How is it a geometric series? Because it originates from 1 over 1 minus x, which is 1 plus x squared plus x cubed plus x to the 4th, and so on. So this is the geometric series where, from high school, dealing with geometric series, how do we know if a given series is geometric? Okay, these things you are yet to do them when you're dealing with Taylor series and Maclaurin series. It's another module. Right, Taylor series, you might have done it. You are yet maybe to do it. Taylor series. Or these we call Taylor series in particular. So or you can call it the Maclaurin. Right, Maclaurin series. Now, this kind of series here tell us that this series here is obtained by using calculus. But now it becomes geometric when we can find the constant ratio from high school. T2 over T1, for instance, is going to be T2 is x over 1, which is exactly x, giving us the constant ratio, x. Oh, the constant ratio, obviously, you agree. It's not only T2 over T1, but we must also check T3 on T2. What is T3? It's x squared on x. And this is only x. And this is exactly the same ratio, because T3 over T2 is x, T2 over T1 is x, and therefore we have a common ratio. The common ratio R must always actually have its modulus less than 1 for convergence of the geometric series. Otherwise, it doesn't converge. Okay, but obviously the notion of convergence is when we discuss series themselves. Right, so, but we are actually effectively saying, in this particular question here, you had 1 over arc, 1 divided by the hyperbolic arctangent of x, and you can write the 1 over is to the power minus 1, and then we use the chain rule. Okay, the chain rule allows us to differentiate a function of another function. How is this a function of another function? Well, it is 1 over a function. 1 over defines a function, but the arctangent is another function. Right, we therefore say, we bring the -1 down, subtract 1 from 1, getting -2, -1, and then the derivative of the arctangent. Okay, we're going to recap all the formulas because you must just always remember the rules in terms of, what the derivative of the arctangent is. But we're going to prove all these. There's a part we're going to do where we're going to prove all the rules in terms of why this is just this way, because that becomes very, very important. Why is the derivative this? You need to understand why the derivative is exactly that one. And yeah, this concept is very similar to what we studied there in when we do circular functions. Okay, and then we study arctangent itself before we even discuss these particular rules. Okay, because this is an engineering course, I would imagine. So it's packed with a lot of mathematics. Yeah, it's packed with a lot of mathematics. We move forward. But we note that the answer to D is not correct. Okay, because they took the answer to C, which is the 2 plus 5, and the cosh of 5x, the hyperbolic sine of 5x, and they just put a minus there. But there's no way you can get even a 5x because these are the rules. The derivative of the arc hyperbolic tangent is 1 over 1 minus x squared. How can it be 5, 4, and so on? I'm just passing there and giving a comment. We move forward. Right, I said we're here to discuss the rules. I'm just looking at the TAT questions now to make sure that at least, we are familiar with these TATs. Now, to find the integrals, these integrals, they're very basic. All these can be done by substitution. All this can be done by substitution. But first things first, we look at part A. Now, when you look at part A, you need to reason because each time integration is a little bit tricky because it's not part of our standard school curriculum. If you've done technical math, obviously the students who do technical math have a taste of integration, but yeah, it's not part of the standard CAPS, so the standard metric. So now you let u be the hyperbolic sine of x. Okay, because we can say that if you find the derivative of the hyperbolic sine, it's the cosh, or the hyperbolic sinh is the cosh. Now we are in business with this because then we can let u be this. So you let u be actually what is at the base of the highest power. And you're able to obtain that the derivative of these is du, which is the cosh of x dx. What is dx? Is du divided by the cosh of x. The integral. Then what exactly is this? Right, wherever you're seeing the hyperbolic sine, we're going to put u. So it's going to be u to the power 6. Instead of sine to the power 6, or sinh to the power 6, is going to be hyperbolic sine to the power 6. Then you have the cosh of x. Dx. Du over the cosh. Next. This cosh cancels out. And the result is u to the 6th power du. Like so. 1 over, by the rules of integration, the integral of x to the power n dx. What is this integral? It's 1 over n plus 1, x to the nth power plus 1 plus c. Okay, we're going to look at that. Yeah, there are times when we're going to spend more time and we're going to engage more. Because obviously this chart presents, we're jumping from one section to the next in an attempt to, because the chart cannot be the whole textbook. And obviously the lecturers are always under pressure. The chart must just highlight what the lecturer has done and what the students need to be in a position to solve in the least amount of problems. The derivative of this one, or rather the integral of this. I'm going to go a little bit to the basics. I know very well that you possibly are very familiar with this. So the integral of the u to the power 6 is 1 over 6 plus 1, u to the power 6 plus 1, plus c. This is what we call an indefinite integral without its limits of integration. Now, 6 plus 1 is the 7. U to the 7th power plus c. U, what is u? Is the hyperbolic sign of x. Ah, there is 1 over 7. Please let's write it down. So this is 1 out of 7. In the place of the u, you put the hyperbolic sign of x plus the arbitrary constant c of integration. Plus the arbitrary constant c of integration. And this is the answer. This is out. Okay, we check. Yes, there it is. It is exactly the answer they wrote there in part A. This is exactly the answer they wrote there in part A. But we move forward to part B of the integrals. Now, in part B of the integrals, we use a formula, a very famous identity. What is it? There's a rule that I always appreciated, but shortcut rule when I was still an undergrad student before I became a researcher. Now, there's a rule that says if you have a function f of x in the denominator whose derivative appears in the numerator, you look at the integral. Normally, they love these in your assessments. A function f of x appears in the denominator, but if you find its derivative, it is the numerator. The answer becomes the natural log of f of x plus the arbitrary c constant of integration. We move forward, and we note in part B the integral from 0. The integral from 0 to ln 3 e to the power x. E to the power x plus e to the minus x dx. Now, this one is easy. You can do it in one step, because if you find the derivative of e to the power x, it is just e to the power x. The derivative of e to the power x is just e to the power x. The derivative of e to the minus x. Okay, each time you differentiate e, it remains the same. Doesn't matter e to the power what, but it has to be e to the power variable, e to the power variable, because it's e to the power. If it is e to the power a number, then the derivative of e to the power a number is a constant. The derivative is 0. The derivative of e to the power minus x is exactly, it's exactly that one. Right, we move forward. So it is e to the power minus x, and then you multiply by the derivative of the top. Derivative of the top of minus x is minus 1. Like so. So if you consider the derivative of the entire, the whole denominator, the derivative of the e to the x is e to the x. The derivative of e to the minus x is minus e to the minus x. Now, because this denominator, when you differentiate it, what you're getting is the numerator. Derivative of this is that it becomes the ln of the modulus of the denominator. And then now it is from 0 to ln 3, like so, giving us the ln of e to the power. You take in the place of x, you put the ln 3. We have ln 3. Right, and yeah, this is very interesting then. Very, very interesting. Okay, yeah. And then you have e to the minus ln 3 minus the ln e to the 0th power e to the minus 0. This is 3 minus, okay, it's a plus here. The e to the minus ln 3 is e to the ln of 3 to the minus 1. In mathematics, e to the ln x is actually x all the time. e to the ln x is x all the time. Why? Why is this? Because if you have e to the ln x is the log of x base e, and this is x. So that this one is 3 to the power minus 1, which is 1/3 when business. So now this one here is the e to the power minus ln 3 is the same as 1/3. Because if you raise e to the ln, is e to the ln x is just x. This is the rule. So now here we shall have this minus. We check the ln e to the power 0, 1 plus 1. The ln 3 times 3 is a 9 plus 1, 10. Out of 3 minus the ln 2. Okay, now you have these here. You can just simplify them using the property of the ln. The ln of A minus the ln of B is the ln of. Okay, we're still here. The ln of A minus the ln of B is equal to what? Let's clean this up. The ln of A minus the ln of B equals what? We write that one down. Take that into account. The ln of A minus the ln of B is the same as the ln of A on B, like so. We good. Okay. Now here, this is the ln of. So if you have the ln of this minus that, it becomes 10/3. You divide by 2. Exactly like so. You're giving us the ln of 10/3. You divide by 2/1. And then what is this? This is actually the ln of 10/3 multiplied by 1/2, which is the ln of 5/3. So the answer is the ln of 5/3. Exactly what they gave. We're getting exactly the answers they gave in the tutorial as part of the TAT. As part of the TAT. We move forward.
So,
Yes, please.
sorry, can you
Yeah.
please explain the part where you said e to the power of ln, e to the power of negative ln 3? How did
Yeah.
you manage to get 1/3?
Okay, that's a good question. How did we manage to get 1/3 from e to the power negative ln 3 to 1/3? How did we actually simplify that? We use the property of the ln, because e to the power negative ln 3, this -1 is taken up using the property of the log, the ln of A, and what is n ln A? N ln A. And ln A is the same as the ln of A to the nth power. So there's a negative here, which is a -1. We can take it up on the 3, so it becomes an exponent of the 3. And the minute we have e to the ln x, the rule is e to the ln x is just x. E to the ln x, in other words, the e cancels ln if ever the ln is the power of the e. So each time that in mathematics you're able to see this, you can think of this as cancellation. So e cancels the ln and you're left with x is the rule. Or you can say e cancels the log to base e, because log to base e is the ln, giving us x. E cancels the ln, giving us 3 to the power minus 1, which is exactly 1/3. 1/3. Okay, why is it 1/3? Well, because you have that e to the ln of 3 to the power minus 1. The e cancels the ln by law, it's a law. And then you have 3 to the power minus 1. But 3 to the power minus 1 obviously is 1/3. Meaning that is why this one here, the e to the power e to the power minus ln 3 is 1/3. Right, and then now e to the ln 3, e to the ln 3 by the rule E cancels E, giving us 3. So e to the n3 is just 3 all the time. And we're able to simplify it to the ln. So it went all the way here to our final answer. And our final answer is the ln of 5/3. The ln of 5/3. Please give it some thought. We're just discussing the TAT, and then we shall do more problems. Okay, we shall do more practice. We shall do more textbook solutions. Right. Shall do more textbook solutions. Right. Okay, let's move on.
Sorry,
Yes, please.
so yeah, since
Sorry. Yeah.
we got an answer of ln 5/3, so
Yes.
it's not a must to also add like the plus C.
Okay, that's a good question. Okay, it's very important. I'm glad that you're engaging and we're thinking about these things, because learning happens when you think. And obviously, it depends on the integral. Like you see in this part here, we added C. And obviously it coincides with the answer to part A. C was added. So when do we add? Obviously we add C when we have no limits of integration. When the kind of integral we're dealing with is actually indefinite. When it is an indefinite what? Integral. When it is what? An indefinite integral. Then that is when you add C. When there are no limits of integration, it's indefinite. And these definite integrals like B, then obviously C is not added. Can we add C in this one with limits? Well, the truth is the C can be added, but it cancels out by law. So the answer becomes a constant, becomes a number without the
Oh
C.
yeah, sorry. Now
Yes,
I
that's
see.
fine.
Now
Yes,
I
it becomes
think.
a number without the C. Yeah, okay. But in principle, I remember can discuss that the fact that after the integral you can add C here, but when you do the minus this, so the C cancels out. So in the end, the C it's never there, you know. It's never there whenever you have limits of integration. And this kind of an integral is called the definite. It's called definite integral. How is it definite? Definite means that it has limits of integration that are defined. Okay, obviously we're just looking at the TAT questions and we're trying to understand this. We're going to also go to the textbook exercises, please. It's not only the TAT, but yeah, we're starting with the TAT. Maybe, yeah, so that first you can be familiar with the TAT. And then we shall make plans to practice more. But now to engage more, because I'm just trying to make sure you're familiar with the TAT and you can agree on the TAT. Okay, on this tutorial. Now we're looking at the cost. You are looking at part C. The cos squared of x, cosecant squared of x dx. Now, this one is always tricky because each time you do this, you must know the rules. You must know the rules of differentiation, okay? Because now you need to know that if you are differentiating this, what you get. If you're differentiating this, what you get, you know? So now, let's check. I want to just recap on the rules. Let us revise the rules a little bit. Like, okay, the derivative of the hyperbolic sign is the cosh. The derivative of the cosh. The derivative of the cosh is the hyperbolic sign. Okay, we can prove these things, but in the assessments, it's very important that you're able to remember them. But now these have no minuses. The cosh and this and the hyperbolic sign, just need to remember that nothing tends to a minus. The derivative of the hyperbolic tangent is the sec squared x. Okay, I know that these things are there in the book, but you know we practice them. And we must make sure we remember them. And then if you have the derivative the derivative, can write here, the derivative of, if we have the derivative of the cosecant, hyperbolic cosecant of x is minus the cosecant, the cos of x, the derivative of the sec of x. What is the derivative of the sec of x? Is minus the sec of x, the tan of x. The derivative of the cos of x, what is it? It's minus the hyperbolic cosecant squared of x. Okay, these are just the derivatives of our 6. 1, 2, 3, 4, 5, 6. 6 hyperbolic functions. So now we need to look at this and decide, because you need to think here and you say that if you let u to be cos, its derivative, if you let u to be cos and then its derivative becomes cosecant squared, then that is going to work. If you let u to be cos, the derivative of the cos is cosecant squared, so that is the substitution that's going to work. What about another student can come and say, if you let u to be cosecant, the derivative of the cosecant is minus cosecant, hyperbolic cosecant, the cos. It's not going to work. So, what works in this case? So we let u to be the cos of x. The du is of the cos is this one, is minus the hyperbolic cosecant square of x dx, meaning that here you have the cos, and then wherever it's cos you put u, so it's going to be u squared. Cosecant squared x dx. What is dx? According to this, dx is du over minus the hyperbolic cosecant squared, which is dx. Yeah. So now this is equal to what? This cosecant squared and minus cosecant squared, they cancel out, giving us just -1 because of this negative. So in this negative, you can put it outside the integral sign because it's a constant. And then now, what is the integral of u squared? It's -1 over 3 u cubed. You add 1 to the 2, you divide by 2 plus 1. And then you add c this time around, because we have no limits of integration in c. So this kind of an integral here is what you call an indefinite integral. It's an indefinite integral. So that we have -1 over 3. The u is the cos cubed x plus c. And this is the answer. This is exactly the answer. But you see, you check what they've written here. You check what they've written in C. There's no way this can be the answer. So they've written a wrong answer. How do you check if an answer is correct? Okay, in calculus, if this is the correct answer, then if you differentiate this, if you find the derivative of this, you must get back the integrand. You see, if ever it happens and you do not get back the integrand, then the integrand is wrong. So theirs is wrong, because if you, what is the derivative of x? It's 1 minus the derivative of the cos. The derivative of the cos of x is minus cosecant squared. So 1 minus cosecant squared cannot be this. Cannot be that one. There's no way it can be this. And therefore, the answer to C is not correct. The correct answer is minus 1/3 the cos cubed x. How do we know that this one is correct, the one we've got? How do we know? We know because we are saying the answer is minus 1/3 the cos cubed of x plus c, which is the answer to the part C. Then if we find d dx, we check by differentiating this answer. You must give us back that. Let's check. So now you find the derivative of this one with the c. Right, so you have minus 1/3. You bring down the 3, and we have the cos 3 minus 1, it's 2x. You multiply by the derivative of the cos. What is the derivative of the cos? The derivative of the cos is minus cosecant squared. The derivative of the cos is minus cosecant squared. So it's minus cosecant, hyperbolic cosecant squared of x. This cancels out. 3 cancels out. Negative times negative is positive. The cos squared cosecant squared of x. Like that. Which is exactly this. So if we differentiate the answer, we claim that is the answer to C, then what we're able to get is the actual integrand. It is the integrand. And this is the integrand here that was integrated. And therefore, it is, theirs is wrong. This, there's no way. Check this. Theirs, if you find the actual derivative of this, if these integrals are correct, you must differentiate them. At least the ones that are not constant, you can't differentiate it a number, but the functions you can differentiate. And then you find the derivative of this, x minus the cos of x. The derivative of the x is 1 minus. The derivative of the cos, we know the derivative of the cos. What's the derivative of the cos? It's minus cosecant hyperbolic squared. 1 plus cosecant hyperbolic squared. What is 1 plus cosecant hyperbolic? You can use the identities. Because what are the identities? Because you know that the cos squared minus the hyperbolic sine squared is 1. Okay, this is an identity that we learn. This is an identity that we learn. So that now you can derive some identities here. You can divide by, if you want to get the, you want to get cosecant squared. Cosecant is 1 over the hyperbolic sine. So you can divide by the hyperbolic sine. Okay, so you divide by the hyperbolic sine. You divide by the hyperbolic sine. So the cos over the hyperbolic sine, this one is actually what? It's actually the cos. The square of x minus 1 is equal to the cosecant, hyperbolic cosecant squared. Which is therefore now, we want to investigate what is 1 plus cos squared. 1 plus cosecant squared. So with this identity, then if you have cosecant squared plus 1. What is cosecant squared plus 1? Hyperbolic cosecant squared plus 1 is the cos squared. Meaning, 1 plus the hyperbolic cosecant, we can say it is the cos squared x. We are trying to prove that the answer is wrong. So we differentiate it. And then now you must be able to get that back. But if you differentiate the answer, the most you can get is the cos squared. And the answer should be cos squared, cosecant squared. But our answer to the part C, cos squared, cosecant squared, hyperbolic, our answer is minus 1/3 the cos cubed of x plus c. And that is the answer. And that is the answer. That is the answer. We move forward. Okay, just practicing with the third questions. And we shall go to the textbook and do as many problems as possible. Right now we are moving forward. And want to try D. So in D, we have the integral. We're doing type 3 of the hyperbolic tangent. The sec cubed x dx. Okay, now to do this one, you know, there are a couple of things you need to remember. You must remember the rules still. You must remember the rules, because if we forget the rules, then we actually are going to take long to find the integral, or we're going to do things that are not going to work, because you must know the technique that's going to work. Okay. Let's remember the rules. Okay, I'm just going to scribble the rules here. D dx, the derivative of the hyperbolic sine of x is the cosh. D dx. Cosh of x is the hyperbolic sine of x. D dx. Tan of x is the secant squared. D dx okay, just writing out the rules. Okay, so that you can remember what the derivative of the six hyperbolic functions. 6 basic hyperbolic functions. So the derivative of the hyperbolic cosecant of x is equal to what? Okay, you can write it here. You can write it here. So the derivative of the hyperbolic cosecant of x is what? Minus cosecant hyperbolic of x, the cos of x, the derivative. What is the derivative of the sec of x? Sec of x is the negative sec x 10x. Okay, so d dx. Okay. All right, so obviously, what is the derivative of the cos? The cos of x is minus hyperbolic cosecant squared of x. Now, if we remember just these ones. Now we need to think here. If you let u be anything, like if you let u to be tan, what is the derivative of the hyperbolic tangent? Is the secant squared. So it's not going to work. If you use the substitution and the student suggests that, okay, let's let u to be the tangent, then it is going to be the sec squared. Now, if you let u to be the sec, the derivative of the sec is sec hyperbolic tangent. It's going to work, but we need to do a little bit of work first. Okay, because integration is about planning the substitution that's going to work, because there are two functions here. You need to decide which one to actually, you know, make u. Which one should be u? So because if you choose a function that is not going to work, then it's, you're going to spend a lot of time not getting the correct answer. So now this means that here you have the search, then here, okay, then the search squared dx. Let us practice with this one. Now, if you let u, okay, let us do this. So you can decide here to let u, you let u be the search of x. The derivative if is the negative, the search, 10x. Oh, it's fine. It's okay. Okay, because we know the derivative of the search. What's the derivative of the search? It's minus search, the hyperbolic tangent. So we're just revising the derivatives of the hyperbolic functions, so that du is negative the search of x, hyperbolic tangent of x, dx. Okay, we put some division here, and furthermore we put some separation, the integral, so that here at this point you have the 10 the search, and then this one, the search. So you can let u be the search, but you put it only here. Very cunning. You put it only there. You don't put the u here and there. No, you put it only in the square, so that it's going to be u squared. But what is dx from this? Dx is du divided by negative the search of x, the 10 of x. 10 cancels, search cancels, negative u squared du. Okay. Minus 1 out of 3 u cubed is the answer, plus c. Minus 1 over 3, what is u? What is u? U is the search. Search cubed plus c. The search cubed plus c. The search cubed plus c. And this is the answer. But the answer looks different, yet it is the same. The answer looks different, yet it is the same. How is the answer the same? Because we know that this is minus 1 over 3, but the search is 1 over cosh. The search is 1 over quotient, then you add c. We add c because there are no limits of integration in D. And the integral in D is called the indefinite integral. Indefinite integral. So indeed the answer to D is correct, but the answer to C, hang on. No, it's not. We've seen that. We've spent a significant amount of time trying to digest the answer to C, but it's not correct. So what you need to do to learn these things? You need to take note of our discussion, and at the end of our discussion, you'll have to spare some time, to repeat these things, to try the questions on your own without looking at the answer, and make sure sort of you can do all of them. That is the beginning, and then it is the learning phase until you become efficient. With me, I've done a master's degree already, but I must tell you, I learned these things when I was still undergrad, but to this day, I still can remember these things because I practiced them. I asked the tutors, and the tutors explained it to me. And then I practiced, and then I asked the tutors. Wherever I was stuck, I was asking the tutors, and then they explained it to me. And then today, I'm a mathematician. I'm a mathematician and studied a master's degree at the University of the Witwatersrand in Johannesburg. That is where I studied my master's degree. So now, but I started by learning these things. And then I learned more and more until I decided, okay, let me become a mathematician and do a master's degree in mathematics. Now on my journey to get a doctorate degree, a doctoral degree. Okay. Anyhow, it's a journey to learn. All right, we continue. Now, we have more problems. That was number 2. Then we have number 3. And I want us to learn the number 3 problems. Okay, if you look at A, for example, you have this particular integral here. And this one, these integrals, all of them have limits. So these are all definite. Are all definite integrals. So we don't add C here. Now, but now you need to check. We're going to do part A, the integral from pi over 2 to pi over 6. Right, so you have the cosine x sine cubed dx. Let u be the sine. Du is cosine x dx. X u. X is from pi over, we can write here. So you draw a small thing, a small cross like this, a small table. And then now realize that x is integrated from pi over 2 to pi over 6. Okay, now you use this substitution. U equals, because we're using the U substitution. So now U is sine x, and then you substitute. What is the sine of pi over 2? Pi over 2 is like 90 degrees. Pi over 2 radians is the same as 180 degrees divided by 2, which is 90 degrees. What is the sine of 90? It is 1. This pi over 6 is the same as 180 divided by 6. 180 degrees divided by 6, giving us 30 degrees. The sine of 30 is 1/2. We can change the limits of integration by a transformation. This is the transformation. 1 to 1/2. This is a strange problem because you must integrate from a smaller number to a larger number. In which case, your lecturer might tell you, you interchange these two limits of integration, and it is possible to do so. Yeah, but anyhow, it doesn't change the answer anyway. So even if you interchange the limits of integration, the answer doesn't change. We proceed. So we have the cosine of x divided by here. Here the sign is u cubed. Dx is du divided by the cos. So you have this. Right, so you have 1 over that, which is 1 over minus 2, u to the minus 2. You find the integral of this. Then you integrate from 1 to 1/2. Then you can remove the small table I wanted to put here because I put it up there already. And there now, let us check what we're able to achieve. You put the 1/2. 1 over 1/2 squared minus 1. Okay, 1/2 squared is what? 1/2 squared is like 4 minus 1, which is 3. So it's minus 3 out of 2. Minus 3 out of 2. So the answer is minus 3 out of 2. Minus 3 out of 2. Any question? Any question? Okay, it's very easy. So it confirms that indeed the answer they gave to part A is the correct one. Okay, we're going to try all these. There are 6 problems here. So move to the problem in part B, which is the integral from 0 to pi and 3 radians. Aha. I was saying the lecturer might say here, this you can change to, because now you're integrating from pi out of 2 to pi out of 6. It's like you're integrating from 90 degrees to 30 degrees. You don't integrate normally from you start from a smaller number to a larger number. In which case, if you interchange the limits of integration, then you need to introduce a negative. Dx. We proceed. B. The integral from 0 to pi over 3 radians. Dx. Let u be the tan of x. Du is the what? The derivative of the tan is the secant squared, dx. So this is u xu. X is from 0 to pi on 3 radians. Okay, u is tan x. What is the tan of 0? Is 0 the tan of pi over 3? Pi over 3 is like here. So the tan of pi over 3, according to SOHCAHTOA, the tan of pi over 3, according to SOHCAHTOA, pi over 3 is opposite of adjacent. Opposite of adjacent is square root of 3 over 1, square root of 3, just. So instead of integrating from 0 to pi over 3 radians, we're going to integrate from 0 to the square root of 3. E to the power, the tan of x is u. And you have the cosine squared. Dx is du over the sec squared x. Okay. Let us check. E to the u. What is 1 over sec squared? 1 over cosine squared is a sec squared. So now, this is the square root. Then we have e to the u du, which is e to the u, the integral from 0 to the square root of 3, which is e to the square root of 3 minus e to the 0, which is e to the square root of 3 minus 1. This is the answer. E to the square root of 3 minus 1 is the answer. So indeed, the answer to part B is correct. I'm going to engage you. Sometimes I must give you a chance to reason with me. I'm going to give you a chance to try some of the questions with me. Because it cannot be a good idea that you just only watch. It's not fair. Because in the end, everything is easy, but you need to follow and you need to engage in class, because then if you engage, then you learn. Because I don't want you to just only watch and then go on like that. Learning happens when we are part of the process. We move forward. I want you to try problem C. I'm giving you a split. I'm giving you a split second to try problem C, and then we'll do it. I'm giving you a split second. I'm giving you a split second. So, right, I'm giving you a split second. So take note of that. I'm giving you a split second. Please let me know when you're done. I'm just teasing you. Then you're gonna do it. Then you're gonna compare the answer to see how well you have. Right. 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 Please let me know when you're done. Then we're going to discuss. So let me know when you're done. Then we discuss.
Yeah. I forgot how to integrate a constant to the power of
Okay, that's
something.
fine. Okay, okay. I'm happy that we're able to recognize it. Okay, I'm happy that we're able to recognize it. Yeah. Right. Yeah. Right, right. So, okay, that's fine because I'm just testing you. I'm just testing you because I'm trying to make sure that you reason with me because then you see, just thinking once. It's what makes the whole difference. It's not about running through all of them because you can write all these and get 100%. I must tell you that most of my students or most of our students get 100% in their assessments, you know. And that is why I was saying, even with your things, if they give you a take home, those take home assessments, you can share those. If you need to submit by the next day, there are some questions you need to submit by the next day. Sometimes they don't give that at university, you know. Sometimes they only teach and then they give a test. So, but they might, you know, some lecturers might give a small little assignment, something like that. So the things you can do at home. And now you need to share those with us so that you can compare the answers, you know, so that you don't just do only your own thing. And then now it will put you in, right. It will put you in jeopardy. Okay, because we don't want you to lose marks. My aim is every student we work with must excel. Okay, every student we work with must excel, must get a distinction at least in the course. And we don't want anything less than that. But now we need to work together because now the submissions you make are the ones that dictate the marks. Right. So that is something important. The correct pronunciation of your name. Right. So okay, we're going on. Never mind. We're just pausing to give you a chance. Now, each time there is an integral of a constant to a variable. Okay, obviously these things are there in the calculus books, but you see, I'm not all about just, you know, cramming the formulas. No, I'm about the rules that work all the time. Each time you see a constant to a variable in mathematics, what we do is you change the constant to base E and you use the ln of 10 to the power x like this, dx. So because in mathematics we know that e to the ln of x is just x. So e to the ln of 10 to the power x is 10 to the power x. It's just 10 to the power x because the e cancels the ln, leaving us with only x, and we use the same rule. Next, we have 1 to 2, e to the power x ln 10 dx. Okay, so let u be x ln 10. du is ln 10 dx. But obviously, when you use a substitution and this kind of an integral, is that these are definite integrals. Okay, you see, they said evaluate the following definite integrals. So at least your lecturer stated these as definite integrals. So let me not write that one again, the word definite. Is now you have the x and the u, change of variable. A transformation exists and has been defined. We let u to be, so now the x is from 1, the integral for x is from 1 to 2. 1 to 2, but now the u is x ln 10. U is x ln 10, so it is ln 10. And then now you put 1 in the place of x, it becomes 1 ln 10 ln 10. And then you put a 2 in the place of x, it becomes 2 ln 10. Right, so we're in business. This means the integral now that we're going to do, instead of integrating from 1 to 2, we're going to integrate from ln 10. We're going to integrate from ln 10 to 2 ln 10, to double ln 10. We're going to integrate from ln 10 to double ln 10. Okay, so from time to time, I'm going to give you a chance to try the problems. What is x ln 10? X ln 10 is u. What is dx? Dx is the u divided by ln 10. And this is equal to 1 over ln 10 is a constant. 1 over ln 10 is a constant. So we take it out. We take out 1 over ln 10. So we can continue up here. We can continue up here by annotation. We're just interested in seeing the answer. So we have the integral of ln 10 to the power double ln 10, or 2 ln 10. We take out 1 over ln 10 e to the u du. Right, so if you integrate now, the e to the u is what? The integral of e to the u is always just e to the u. Then integrating from ln 10 to 2 ln 10. 1 over ln 10 e to the power. We substitute the upper limit of integration first. 2 ln 10 minus e ln 10. Now, this is 1 over ln 10. E to the power ln of 10 squared e ln 10. We can finish it off here. So now we actually have the following. So you have 1 over ln 10 e to the ln. E cancels the ln. E cancels the ln, giving us 10 squared. 10 squared is what? Is 100. E cancels the ln and giving us only 10. What is 100 minus 10? It's 90. So we have 90 divided by ln 10. 90 divided by ln 10. And that is the answer. 90 divided by ln 10. And that is the answer. 90 divided by ln 10. That 90 divided by ln 10 is the answer. So we have been able to integrate a constant raised to a variable without using the book. Okay, because you can see that sometimes obviously you use the book, use the like in the curvilinear coordinates, I saw the solution, you cited the formula for the integral. Yeah, I know, to save time, because but it's very important you learn the methods. Because in general, I know that the calculus book will say 10 to the power. It will say a. Okay, there's a formula in the calculus book, but now with me, I don't believe in those formulas. I want to do things from first principles, step by step, so that I don't memorize anything. I can use the formula because I've learned the formula. So if it's a to the power x, it is always 1 over ln a to the power x plus c. But again, this is about memorizing. Why is it 1 over ln? Now we prove everything step by step, and we're able to get the answer 90 divided by ln 10, and that is the answer. We proceed to the next point. Right, the next question is D. Let's try D, and D is about the logarithm. But this logarithm in D is base 2. Be good, but let's check it out. So this one here, right, as you remember that we have a new Miss SA. We have a new Miss South Africa. So now the new Miss South Africa was announced yesterday evening. Right, Mia Leroux is our new Miss South Africa. Mia Leroux has been crowned Miss SA 2024. So this is something we need to celebrate. It's an achievement for us. It's an achievement for us. So we must not forget this, because these are the things that make South Africa the country it is. Okay, anyhow, let's continue. We're dealing with this one. Yup. Now, to integrate these things here, you need to reason, and each time in school we use the log called the common logarithm. Right, we use the common logarithm in school, but at university we don't want it. Right, at university we know that if ever you have been given the log of x base 2, you must change it to ln. Must change it to ln. Well, ln, x stands for logarithmus naturalis. And in English, because it's written as LN because of the foreign, Latin, and French languages. But now in the English language, we read it natural log, natural logarithm. And it's not just in, it's not in x. You know, some students begin thinking it is in x. It's not in x because it is natural log of x. Just right mentioning these things. And the ln stands for the natural log. What is the natural log by definition? Because we must know. Now here, natural log, we use the law of change of base. Look, x base e divide by the log of 2 base e. Look, x base e, you divide by the log of 2 base e. What is this? This is ln x divided by ln 2. Okay? Right. Okay, there are no sections that are going to be open discussions. I love open discussion, but now I'm just doing the TAT. But you see, the problem in the TAT is it's jumping too much from one problem that is like this to another different one. So you don't have a fair treatment. And I cannot be fair to engage you a lot in terms of, you know, attempting to reason with me. Because then it's not fair to you. Because now you're seeing a question like this, then I ask you to participate in a problem that is very different. Then you'll be like, I don't know that. Okay, because it's different. So we need, okay, we're back. So the integral of this, x, the log of x base e. E to e squared dx x. What is the log of x base 2? The log of x base 2 is the same as ln x over ln 2. Ln x over ln 2. E to e squared. Ln 2 divided by x ln x. Ln 2 e to the e squared. 1 over x ln x dx. Okay, everything must be changed to ln for us to handle. Right, so because that is why even the answer to D you can see is in terms of ln. But this answer can be written in terms of the log. But you can see even the lecturer realized that, hang on, just change everything to ln. Because this answer can be written in terms of log base 2. It's possible. You know, but it's not very nice because the things we do in calculus are just done in terms of ln. So we change everything. But now let us reason as follows. We're in business now. Here we're going to let u be the ln. If u is the ln, then we can find the derivative of the ln, which is 1 over x dx. We are back. We are back. Now, xu e to e squared. U is ln x. What is ln e? Is 1. So you do u ln e is 1. U, the ln of e squared. What is the ln of e squared? It's 2 ln e. What is ln e? Is 1. 2 by 1. That. Okay. Okay. Here you have ln 2, the integral. So instead of integrating from e to e squared, we're going to integrate from 1 to 2. Moreover, with x, okay, the ln x in the denominator will just be u. Will just be u. What is dx? Dx is x du. X du. X cancels. Ln 2, the integral from 1 to 2 of du over u. So that in the end, ln 2, ln u from 1 to 2. So what is this? This is the same as ln 2 minus ln 1. Ln 1 is 0. Then we have ln 2 times ln 2, which is the ln of 2 squared. And that is the answer. The ln of 2 all squared. The ln of 2 all squared. So we've been able to show that the answer to D can be converted to the ln, and then we can be able to see that the answer is the ln of 2 all squared. Ln of 2 all squared. All right, so we have been able to do part D. Without wasting further time, we proceed to the next one.
Sorry,
Yes, please.
can you please re-explain the part where you change the log into the ln?
Okay, good. It's called the law of change of base. The law of change of base. Right. Law of change of base. Right. The law of change of base. So obviously what we have is that whenever you want to change, what is the base here? The base is 2. It is log x base 2, but not to change, want to change the base. So we're going to use, right, log x divided by log 2. Log x divided by log 2, but we change the base from 2 to EE. Because in mathematics, we know that the log of x base e is ln x. What is ln? Ln x is log of x base e. So now it means that we want to change the base from 2 to e, then we can write log x base e divided by log 2 base e. What is log 2 base e? Log 2 base e is the ln. Log x base e is the ln. So we have that. We have exactly that. So I don't know if that is clear enough. So that now if we have the log of 2 base e, the log of x base e is ln x. So the log of 2 base e is ln 2, and the log of x base e is ln x. So now that has allowed us to sort of convert the log to the ln for integration purposes and differentiation. Because if somebody can ask, what is the derivative of, we find the derivative of the ln, because the derivative of the ln is 1 over x, like here. We said, let u be the ln x, then the derivative, we know it's 1 over x. But we don't find the derivative of the log base 2. You can, but it's not nice. Because if it's just ln x, then derivative we know is 1 of x. What was the derivative of, you see, these things can be done. But if for you to find the derivative of log x base 2, you'd have to find the derivative of log x base 2, you have to convert it like this. First to the ln and then differentiate. Because the things we learn at university, everything is taught in terms of the ln, not in terms of log, not in terms of the log. So that is something that you need to take note of. So, but obviously here we're just discussing the third questions. So we are just sort of confining ourselves to the tutorial questions, in which case the time is coming when we shall elaborate and do more and do more questions from the book. And that must be today. That must be today. All right. So all is well. Okay, now without further ado, we need to proceed to the next question and practice with it. The next problem is problem E. We try E, and now E is easy. Let's check this one. We have the integral of 0 to 1, x squared divided by 1 plus x to the 6th power dx. 0 to 1. X squared divided by. There's a little trick here. It's x to the 6th power, but now you can see that there's x squared here, which appears to come from the derivative of a cube. So which means that you can write this one as x cubed squared dx, like that. Now from x cubed, the derivative of x squared can be obtained. The derivative which is x squared can be obtained. So which means that we are in business and we let u be x cubed. Du is 3x squared dx. The integral xu 0 to 1. U is x cubed. 0, 1. 0, 1. X squared. 1 plus. What is the x cubed? Is u. So it's going to be u squared. Okay, integration. So you need to repeat these problems. What is dx? Dx. Okay, there might be a school kid that is joining us. Okay, sometimes I encourage school kids to join and get information because they don't know. Okay, we have WhatsApp groups. So now this kid might have joined the WhatsApp group. I think that is just playing that home because I sent the link yesterday and this kid did not join. Okay, let me speak to this kid. It's a school kid. Right, Sinekamva. Hello, Sinekamva. Sinekamva. Okay, dx is, this student is not talking. Dx is du divided by 3x squared. We cancel this, meaning we have the integral from 0 to 1, 1 plus u squared du. Okay, now we go back to the rules. What is the integral of these? So the integral of 1 plus x squared dx, what is this integral? It's arctan x, but you can also write it as arc, the trigonometric tangent of x. So this one is arctangent of x. Arctan 1, arctan 0. And then this is arctan 1, arctan 0. Arctan 1 is pi over 4. Okay, but remember, please, there's 1 over 3 here. From the 1/3, 1/3. And you can write 1/3 here also. One-third. So 1/3. Okay, so this one, 1/3. Pi over 4, arctan 0 is 0. 3 times 4 is 12. The answer is pi over 12. Pi over 12. So indeed, the correct answer has been obtained there. It's pi out of 12. Pi out of 12. Okay, we good. We're so good. We're so good. We're so good. So now we proceed to try the next problem. What is the next problem? The next problem is F. Right. In F, it's easy, but I must give you a chance to try F, and then we shall do it together. So now, okay, Sinekamva is gone. Okay, it was just some kid joining from our WhatsApp group. So now you can try F. I'm not interested in the whole answer. I'm interested in the first step. You'll forgive, I'm trying to make you think a little bit so that you can learn something. Because it's not comfortable for me to reason. I felt so uncomfortable when the tutor, I had tutors, I had tutors when I was small. I had tutors when I was still in school. And then sometimes they could give me a problem, and because I was asking them questions, there was no this thing of Zoom at the time, or Teams, you know. So right, so you see, okay, you see, I never felt comfortable, but you see, it challenged me because I could be like, okay, I'm comfortable with just watching you doing the stuff because with me, I'm still learning. So now you can then say, okay, but I'm still learning. Then the tutor could be like, can you try this one? But I could be like, I don't know. But it changed my mindset. Changed my mindset. Today I'm a mathematician and I've done a master's degree. But my journey was from primary, high school, university. You know, that was the journey. So now I'm interested in the first step in F. What could you do first? First things first. What can be done there? I know it's easy. I know we can do it. And you're going to do it anyway. It's not that. But I must be fair that in my years of teaching, I've been a university tutor and I've also become right. 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 So we continue. We continue. Right. We continue. How far? Okay. How far? How far? Never mind that.
So, like, must I approach this question using that property of way we have to change the constant?
To E.
Yes.
Yes. Yes.
Okay.
Yes. So we continue. Now let us deal with F. That's fine. Remember, I'm just teasing you to reason with these things. So the aim is not to cause harm or panic. Is to say you can tease your mind, and it's enough for me to then say, okay, we can use the same method we used. Right. So now you have so it is the integral from 1 to 4. Dx. So you can write like that. Possible? Okay. And then at this point, you let u be the top. Okay, this top you can write in many ways. Like you can take the whole thing. Let u be minus the square root, which is minus x to the 1/2. Du dx. And this is minus 1 over 2 the square root of x. Okay, now we can change the limits of integration. X is from 1 to 4. But now we change to u. U is minus the square root of x. So minus the square root of 1 is 1. So it's going to be minus 1. Minus the square root of x minus the square root of 4. Square root of 4 is 2, but it's a negative. So we're going to integrate, therefore, instead of integrating from 1 to 4, we're going to integrate from minus 1 to minus 2. With that. And then now we have 5 to the power u. And then the dx. What is dx? Okay, you can write this properly. What is dx? If you cross multiply here, minus 2 the square root of x du is dx, which is the integral. So we can write here. It is the integral from minus 1 to minus 2, 1 over the square root. The square root of x. 1 over the square root of x. 5 to the power u. 5 to the power u. Okay, what is dx? Dx is minus square root in minus 2. In the place of the dx, let me write properly. Okay, so we are right here. And then now, feel like I need to write this step here. Instead of integrating from 1 to 4, you integrate from minus 1 to minus 2. 5 to the power. Five to the power u. What is dx? Right, dx is this one. Dx is minus 2 the square root of x du. Minus 2 the square root of x du. Like that. Okay, you can put some bracket here. Okay. This cancels. Okay, let us continue. Which is minus 2. 5 to the u du. Minus 2, 5 to the u du. What is this? The minus 2 can be taken out. And we have that. We are back at the same thing, like here. Like the 10 to the power. The 10 to the power. This 10 to the power is exactly that. Okay, let's continue. Okay, now we are having this one. Which is e to the power 5 to the u du. Which is e to the u ln 5 du. So what exactly are we able to achieve out of this? Okay, because of this now, we have a bit more work to do here with this one. So you have minus 2, the integral from minus 1 to minus 2. Okay. And then we have e to the u ln 5 du. You let v be u ln 5 dv ln 5 du. Meaning here you're going to have minus 2 the integral. We're changing the limits of integration from u to v. U is minus 1 minus 2. V is u ln 5. So it's going to be minus ln 5. We put minus 2 here. It's going to be minus 2 ln 5. Okay, ln 5. What is the u? It's dv divided by ln 5. Which is minus ln 5. Minus 2 ln 5. E to the v dv. Okay, let's check what we have here. Right, so this is minus 2 out of ln 5. It's e to the, you put minus 2 ln 5 minus e to the minus ln 5. Okay. So we have this here, which is e to the that. E to this is the same as just 5 to the minus 2, and this one is the same as 5 to the power minus 1. In the way we explained previously, where it was 1 over 3 minus 2 ln 5, 1 over 25 minus 1 over 5 ln 5. 25, 1 minus 5. So now, which is minus 4 25. And then now minus 2 times minus 4 is actually 8. 8 minus 2 times minus 4 is 8, and then is 25 ln 5, which is this. So this answer is correct. That answer is correct. Right, we are moving forward to try and finish the start. We shall see how far we shall go. Obviously, I mean, doesn't mean we need to finish. We need to be here the whole day to finish the whole start. No, but we are trying the most. Yes, please. Any question?
Yes. Can you please explain the parts where you converted the minus 2 ln 5 into 5 to the power of negative 2?
Okay, yes. That one is because of the fact that the e to the power minus 2 ln 5, it is e to the ln of 5 to the minus 2. So let's just do that here. E to the minus 2 ln 5 is e to the ln of 5 to the minus 2. By using the property of the logarithms, because the ln of x ln a is the same as what? X ln a is the same as what? X ln a is the same as the ln of a to the power x. So that here, once you take up the minus 2 here, e cancels the ln. So that you're only left with 5 to the minus 2, because e cancels the ln by property, because e to the ln x is just x. So that 5 to the power that is 5 to the power minus 2 is that, and therefore 5 squared is 5 by 5, and this gives us 25. So that indeed this one here is the same as 1 over 25. So which is exactly what we wrote, because now the e to the minus 2 ln 5 is 5 to the minus 2, which is 1 over 5 squared, which is 1 over 25, and that is the answer. And therefore, we have 8 over 25 ln 5. Okay, we continue. We continue. We continue. We continue. Now let's try other problems. Okay, we're just doing the start. We shall do as much as possible until like 30 something. Until 37. Somewhere there. Until like 8:40. Then we're gonna take a break, then we can return later. I'll find out from you the time. So for example, 8a, you need to derive the identity that the search of x is 2e to the power x divided by e to the power 2x plus 1. Let's do this one. So to do this one here, we have the search of x. The search of x is actually the same as 1 divided by the cosh of x. What is the cosh? Is e to the power x plus e to the minus x, you divide by 2. 2 divided by e to the power x plus e to the minus x. When you get to this point, we have 2 divided by e to the power x plus e to the minus x divided by e to the power x divided by e to the power x, which is 2e to the power x. Then e to the power x times e to the power x is the same as e to the power 2x, but e to the power x times e to the power minus x is just 1. Voila. And we've got this, and we say Eureka. Right, by then saying Eureka, we've got it, because we know whenever we have the search of x, it is 2e to the power x divided by e to the power 2x plus 1. So these things you need to take the tart again and then try during your own leisure. It is my dream, my wish that we go through the tarts today. Mostly those tarts, because this is tart 3 and then up to the 16th of August. But yeah, we must go through the tarts and the others also, not just this one, but the others on the areas and the volumes. that obviously we can just be show the dots, and then we shall go to the textbook. Okay, now this is exactly what we have. So we have been able to derive the identity that the search of x is 2e to the power x divided by e to the power 2x plus 1. We look at the part B. So that if you have the integral of the search, therefore, it is 2e to the power x divided by e to the power 2x plus 1. Okay. So now you let u be e to the power x, and the derivative is du, which is e to the power x dx. You come to this, which is 2e to the power x, and then this one. This e to the power 2x, you can write it like this, plus 1 dx. Because this e to the power 2x, you can write it like e to the power x all squared, giving us u squared plus 1 dx. Here you can make dx a subject. So du divided by e to the power x is dx. So that wherever you have dx, you can write du divided by e to the power x. But here this is 2e to the power x. To du this arctan u plus 1. So this arctan u, you can write it as ARC for the arc, the tan of u plus c. You get to this point, it's 2 ARC. 2 ARC, 2 arc, then arc the tan of u. U is e to the power x plus c, like that. Okay. Okay. All right. All right. So, yeah. Okay. Okay, we're good. Okay, we proceed to the next one. To the next one. Okay, now you need to evaluate the following integrals involving what you call integration by parts. Integration by parts. So integration by parts, there are many methods of integration by parts. But now you have learned, maybe you have learned u dv. Did you learn u dv? Like the integral of u dv equals uv minus the integral of v du. Okay, this is a popular formula. But you can also do without this formula.
Yes, we did with this one.
Yeah, okay, yeah. Because I was just thinking, it's popular, it's easier to learn, I think. But yeah, we can still do without it. Like when I was still first year, I was not taught UDV. I was taught direct method. And that is what I'm going to use first. And then we're going to go to the UDV. Now we can always do without UV and so on. So now to find the integral of 2x squared cosine x dx, you do what? You check these two things. You check x squared and cosine x. And then look which one can be differentiated and its powers decrease until the expression vanishes. So we can see that 2x squared can be differentiated, because if we choose to integrate 2x squared, so you must integrate one and differentiate one between these two. So now we're gonna differentiate 2x squared. So you put the 2x squared outside, then you integrate the cosine. Minus, then you put a big integral sign like this. You take the 2x squared, you differentiate it, you get 4x. Then you have the integral of cosine x. You write this one as it is. You just put the derivative there, and then you put the differential. The integral of the cosine becomes the sine. So you have 2x, then you have the sine of x. Then you're done with this one. Then you come here. This 4 is the constant. You can pull it out. Then you have the integral of the x is not a constant. The integral of the cosine is sine x dx. So you can see that this one must still be integrated. So which means that you have 2x squared sine x minus 4. The integral of this is x sine x dx minus the derivative of that one is 1. The integral of sine x dx dx. That one sine x minus 4. The integral of the sine is minus cosine. Minus x cosine x minus. The integral of the sine is minus cosine. So you have minus cosine x dx like this. This is 2x squared sine x minus 4. Okay, multiply through by the 4. Negative by negative, it's 4x cosine x plus 4, but it's going to be a negative. Okay, this is negative by negative is plus. Okay, I know our time is up. Negative by negative is plus, and then you have the minus. So you have the minus the integral of cosine x dx. Like this. You can write the final answer here, which is exactly equal to 2x squared. The sine of x plus 4x cosine x. Then you have this one. The integral of the cosine is sine x. So it's minus 4 sine x plus c, which is exactly this. 2x squared sine x plus 4x cosine x minus 4 sine x plus c. Okay, I've just done this one using the general rule of integration. What is the formula for this? Generally, if you're doing the integral in this, you are faced with, you choose one of the function to become we have fg dx. So what you do is you take f, you integrate g minus the integral of, you take f primed multiplied by the integral of g, then you put d like that. Right. So this is the answer. So now this is the formula sometimes I like using because I just go straight and integrate straight away. But either way, the problem is now sometimes, you know, maybe it's the UDV have become popular in the calculus books. So we're gonna use the UDV. Let's use the UDV. So using the UDV now, you have the integral of 2x squared cosine x dx. So we're gonna use the formula that says the integral of u dv is uv minus the integral of v du. Let u be 2x squared. Once you take u to be 2x squared, then dv becomes everything that remains, which is cosine x dx. Let's find the derivative of this one. So du becomes the derivative of 2x squared becomes 4x dx. Here you integrate both sides. Dv, the integral of cosine x dx. Integral of cosine x becomes the sine of x. Whenever you have the integral of 2x squared cosine x dx, according to this formula, it must be u. U is 2x squared. U. And then v is sine x. So we already got this term. of the answer we want. But now we must minus the integral of v du for x dx. Okay, now 2x squared sine x minus 4 the integral of x sine x dx. Okay, so now we are again back to this. And to integrate this one, you again let u be x. The dv would be everything that remains. If u is x, then the dv is sine x dx. Du is derivative of x is 1. Dx, the integral of this one, you put the integral both sides, sine x dx. The integral of dv is that. The integral of the sine is minus cosine x. We're good. We're done. Effect.
So,
Yes.
yes, may I ask?
Yes.
If I want to like how do I know which one to make as u and which one is going to
To
be
make
dv?
dv. Good. Yeah, that's a good
Yes,
question. Which one to? Yeah, because see, a student can make a mistake here. For example, if a student is going to choose u to be cosine x, then it's not going to work, because then the student is going to integrate. Then the student is going to choose, the student can choose dv to be 2x squared dx, or you choose dv to be like x squared dx. The problem with that is that choice is, if you choose dv to be like maybe 2x squared dx, then the problem is the powers of these are going to increase all the time, because if you integrate the 2x squared, it becomes 2x cubed over that. And you integrate again, it's going to be x to the 4th power over that, x to the 5th power over that. And we want, the choice becomes, is done sort of to reduce the powers. And it's only when we can find the derivative of the 2x squared that it becomes like 4x and the power reduces. Because now the integration is made complicated by the x squared power. So we try to destroy that. Okay, and to destroy that, we make it u. So u is that kind of thing that when differentiated, its powers will decrease. So that now we're right back, and we're then saying we have 2x squared cosine x dx. It is equal to this, which is 2x squared sine x minus. Okay, we have to do like textbook problems, and then we can practice more. Yeah, so we have 2x squared sine x minus 4. What is the integral of x sine x? We've already made everything, because now we can see that x is derivative. It's gonna, if we choose u to be x, then the derivative is just gonna be 1. So the x is gonna be just a constant, which is easy. Then otherwise, then we then make the dv to be sine x dx, and which means that now we have dv sine x dx, and then we can integrate both sides, so that v is minus cosine. We're good. Yup. So that now, look, we use uv. So this is the integral here. We are here. The integral here. So the integral of this is going to be u. What is u? Is x. V is minus cosine x minus the integral of v, which is minus the integral of v. V is minus cosine x. Du is dx. What is the answer? So you can write the answer here. The answer is actually 2x squared sine x. And then we have negative, negative, which gives us plus 4x cosine x. This is plus minus 4 cosine x dx, which is exactly 2x squared sine x plus 4x cosine x. The integral of the cosine is sine. It's plus sine plus that. It's exactly this. So we got 2x squared sine x, 4x cosine x minus 4 sine x, and we got that. Right. I know that we've been here for 2 hours, more than that. So it's okay for now. We've done up to this one. Then you're going to try the others, and we're going to meet again later on. But I think that later on we can meet for more time, meaning if you have stuff to do, try to do your things. We might sit for 4 hours. We might sit down for 4 hours. But now, but you need to do your things. Maybe you need to cook. I don't know. You need to plan your things. You need to do other subjects. You need to write your project, you know. And then when we meet, I'm still looking at the time because yeah, there's always a meeting at every weekend from 4 to 6 in the afternoon. 4 to 6 in the afternoon, it's school meeting for the school kids. And then now, every Saturday and Sunday that happens. But I'm planning that we can meet earlier. I'm gonna alert you, but I know it's not fair to just alert you in short notice. But I need to be very careful because another student said we can meet at 2. Then if we do 12 to 2 with another student, we're gonna do 12 to 2, and then we're gonna do 2 to. Okay, the other student is gonna do 2
No
to.
problem. Thank you.
Okay, fine.
No
Thanks. So yeah,
problem. Thank you.
I will alert you. I will alert you. Okay. All right. Okay. Okay. Thanks for now. Thanks then, and goodbye for now. I'm gonna post the video so that you can watch. I know. Okay, you told me YouTube is not the best of your stuff. Okay. I understand that YouTube is not the best of your stuff, but